Alright, this is video 4 and this is surface area of pyramids and prisms. Alright, and on our last video we talked about prisms and pyramids, and today we're actually going to dive into surface area. So the sum of all the areas of the faces and bases is surface area. Okay, if we look at a shape like this rectangular prism, to find our surface area, it's kind of like we can unfold it and we're going to find each base and each one of these faces and add them all up together. Okay, and so that's just kind of a visual for us, is I'm going to find the sum of my two bases, these two squares, then I'm going to add all the area of each one of these sides. All right, and so we're going to jump in. We've got a few examples today, and we'll just get started. So with this, first we have a rectangular pyramid because we have a rectangle base. So first let's find the area of the base. All right, so we've got 15 times 15 because it is square, and that's 225. Okay, now we have to find all of these triangles, all these sides. So I know my height is 12, the base is 15. Okay, and 15 times 12 times 1/2, that's 90, but we're going to actually take that times 4. Okay, so if you want, you can write it out 3 more times, but we're going to add all of these together. All right, so we add these up, and our surface area is 585 feet squared. Okay, so that's all 4 of these triangles that make up the sides and our bottom for the base. All right, our next example. Okay, we're looking at a triangular prism. Okay, so we've got triangles as our bases, and we've got 3 sides. So first, to find our base, we're going to take 8 times 15 times 1/2. We get that from our base. Okay, and this would be 60, but we're going to add it again for the top of this, so we've got another 60. Now let's find one of our sides. So we've got 8 by 4. So we've got 4 rectangles here that we're going to add in. Then we have 15 times 4. And then 17 times 4. Okay, and we can add all those up together, and we get 280, and this is meters squared. All right, for our last example of this type, it's a little more difficult. We have our base, we have the height of the pyramid, but we actually need to find that height, okay? And so we're going to have to do a little bit of Pythagorean theorem. So we're going to find this triangle, the hypotenuse of this triangle, and then we'll be able to solve. So we've got 15 squared plus our other leg will be 6, and that equals c squared. And this is going to be a little ugly. We get 261 equals c squared. So if we simplify that, and if you have a calculator like this, these are really handy for stuff like this, because if I take the square root of 261, it will simplify it for me. And this is our exact answer. Okay, we don't want a decimal right now because we want our exact answer. Okay, so it's a little messy, but we can hang with that. So our Our bottom is 12 times 12. Okay, that's square, so it's 144. And then we're going to find our 4 sides. So remember, it's base times our height times 1/2. And when you have something like this, it's kind of messy to try to think about it. Just type it in your calculator. 12 times 3 square root of 29 times 1/2. And we get 18 square roots of 29. So it's like we have that square root 18 times. Okay, now that's for one triangle. Well, we need that 3 other times. So we can take this and we can just say 18 square roots of 29 times 4, because we want all 4 sides. So we can multiply that by 4 and we get 72. So for our exact answer would be 144 plus 72 square roots of 29. And we're at centimeters squared. But that doesn't make sense to a lot of people. You're like, I don't understand. Okay? Well, simplify this. For a final answer, that's when you can reduce that and get your approximate answer. So we can say 144 plus 72 square roots of 29, and that's 531 centimeters, and let's say 7.3. Okay, sometimes we can just approximate, but don't do your approximation until the very end. All right, moving on. We've got some word problems. I know those are everybody's favorites. All right, so here Tamika is restoring an antique storage chest that is in the shape of a rectangular box. When I see a word problem, I automatically try to draw a picture, okay? So she's got a rectangular box, and your pictures don't have to be perfect. All right, and the trunk is 4 feet long, 18 inches wide. Let's change that to feet, so that'd be 1.5, and it is 2 feet tall. And then it says there's a brass ornament on the outside of the trunk that takes up an area that is 1 square foot. Okay, and that's our little brass ornament. And it's 1 square foot, so we'll call this 1 by 1. All right, we want to know how much paint does she need in square feet to cover the outside of the trunk. So let's find the surface area of this. So let's find the top and the bottom first. So we'd 4 times 1.5. Okay, and that equals 6. And we need it again for the top. So 4 times 1.5. And then we need 2 sides. Let's do this long side first. So this would be 4 times 2 and another 8. And then we'll do our small end, which is 1.5 times 2, which is 3, and then we'll add another 3. All right, so we can add all these numbers up. 6, 6, 8, 8, 3, and 3. Okay, and we get 34 square feet. Well, remember it says we've got this little brass ornament that takes up 1 foot. So subtract that 1 foot, and we get 33 square feet. And you can write square feet written out, or you could just say 33 feet squared. Okay, either of those will be acceptable answers. All right, our next problem, and this is our last example. We've got a new brand of cereal, and we want to know how much it's going to cost to make the cardboard box. Okay, that's enough information to know to draw a picture. Okay, always draw a picture. If you have trouble with some problems, especially in geometry, if you ask your teacher, hey, I need help, probably the first thing they're going to say is, did you draw a picture? Okay, they help tons. And it doesn't have to be a good picture, it just has to be a picture. All right, so there's my cereal box. And it is 2.5 feet wide, or 2.5 inches, 8 inches long, and 11 inches tall. Okay, and eventually we want to find the cost to produce 1,000 boxes. Well, let's just find how much surface area first, because it says it's half a cent for every square inch. All right, so we're going to use the same process, except we're going to simplify it. Up here, we wrote everything out twice. We're going to say 2 times everything. So this first one, we're going to take 2 times our biggest surface, 8 times 11. Okay, so we'd have 8 times 11 is 88, times 2 is 176. Okay, the next one, we're going to take 2 times our little small, 2.5 times 11. Okay, and so this would be 55. And then, let's see, what's our last? We need our 2.5 times 8. All right, and 2.5 times 8, let's see. That would be 20, and twice would be 40. All right, so we're going to add all these up together, and we get 271. And this is inches squared. All right, now it says it costs half a cent for every square inch. So we take this and we divide it by 2. So it means it costs 135.5 cents for each box. Let's go ahead and change that to dollars. So $1.35.5 and a half. Actually, let's just go ahead and let's get rid of that half. Now we can take that and multiply it by 1,000. Okay, so it's $1,350. Now, if we would have kept that 5, we would have gotten $1,355. So you can see the importance of changing of if we were to round before or after, okay? So this is why it's important. That's a difference of $5. It's a little messy there. Okay, so that just shows don't round to the very, very end. Okay, and our last little tidbit is sometimes we might have a composite shape where we have maybe a cube and a pyramid, or prism and a pyramid together. Sometimes you won't need every side. For example, this bottom if we were counting surface area, we wouldn't need the bottom of the triangle of the pyramid, because maybe we're just looking at the outside. Okay, we wouldn't, if we were painting this, we wouldn't be painting this red section, it'd just be the outside. So just be careful and be aware of that.